Alright, so we have absolute value equations. Now recall, an absolute value of a number is the distance from 0 on a number line, so it's always going to be positive. So an absolute value of 3 is going to equal 3, and the absolute value of negative 3 will equal 3 as well. When it comes to absolute value equations, you have about 5 steps to do. First and foremost, the first step is you have to isolate the absolute value. Once it's isolated, you need to sort of see what it's set equal to. Now, if it's set equal to a negative, stop because you're going to have a no solution. Now, if it's equal to a 0, you can only have one possible solution. Now, if it's equal to a positive, you can actually have 2 possible solutions. Now, because of having 2 possible solutions, you have to set up 2 equations. The first one's going to be the original. It's going to be the as is, drop everything down, except the absolute value signs. The second one is you're going to change all the signs inside the absolute value sign. And then once you get your answers, you're going to check your answers. This comes super important when you have it set equal to an expression because you don't know what it's set equal to. So let's look at a few examples. First one, we have to isolate the absolute value signs. So we have this negative out front, so divide by negative 12. So bring down the absolute value. Now, it's isolated, but it's set equal to a negative, so huge red flag because this is going to be a no solution. On this one, we need to go ahead and isolate, so we're going to add 5 to both sides. So bring everything else down. We still have that 3 in front, so we need to divide. Now, it's set equal to a positive, meaning that we need to have set up 2 equations. Now, the first one's going to be the original, as is. So just drop down the absolute value. And the second one's we're going to take the expression inside the absolute value and change the signs, but set it still equal to positive 5. So subtract the 6 from both sides on the first equation. Don't box it because we're not 100% sure. Add 6 on the second equation. And then divide by negative 1. Now, when you do your check, it has to be done in the original equation. Once we plug in negative 1 up here, it does equal 10, so this works. Same thing for negative 11. When we plug negative 11 into x in our original absolute value equation, it equals 10 as well. So since both of these work, we include them both in our set notation, or a solution set. Now in this equation, the absolute value is already isolated, but now the difference with this one, we have this variable in here, so set equal to an expression. This is where you have to truly check your answers. Now since it's already set up and it's already isolated, you have to automatically write 2 equations because we do not know what it's set equal to. And then change the signs on the inside here. So we're going to go ahead and move our 2m over. And then subtract our 15. And then divide by 3. So negative 4 is a possible solution. Go to our second equation, add your 2m. And then add your 15. So when we do our check here, when we throw negative 4 into here, we're going to get the absolute value of 11. When we throw it on the other side, we're going to get 11 as well. So this works. Now when we do our check in here, when we throw 18 into our absolute value up here, we're going to get 33. When we throw it on the other side, we get a negative 33. So this does not work, so we only have one possible solution of negative 4 in your solution set. Now, when it comes to inequalities, once again, the first step is you have to isolate the absolute value. Once it's isolated, now, once again, when you have that negative on the other side, you have these special cases. If it's less than or less than a negative, you're going to have a no solution as your answer. So don't go any further. Now, if it's greater than or equal to a negative, you're going to have an all real number as your solution. Otherwise, you're going to just break into 2 equations just like we did with the equations. Now, when you have your answer, you have to write it in the set notation. But to figure out when you use and or, it depends on the inequality. Once it's isolated, if you have a great or inequality, you're going to write as an or compound. Once when the absolute value is isolated and you have a less than, you're going to write as an and compound. So luckily enough, the word for the inequality sort of represents what compound to write it in. So let's look at our first equation here, or inequality. So we're going to add 7 because we have to isolate the absolute value. Now, it's less than a 2, so it's positive, and we have an and. So just go off to the side and sort of write and to sort of remind you what you have to write your answer as. So write our two equations. We have the as is, and then change your signs. So first equation, subtract that 2, and then divide by 2. Don't do anything with this until we get to our final answer. Our second equation, you're going to add your 2, and then divide by -2. Remember, dividing by a negative, flip that inequality. So we have our two inequalities, and we have our and compound. So to write our answer, we're going to say all the values of k such that. Now in the and compound, we have the smallest number comes first, less than or equal to your variable, less than or equal to 0. And then when we have our number line, when we sketch a graph of this, put the smallest number, then 0. They're both closed circles. And remember, the and compound, the graph overlaps. So you have that graph in between. Isolate the absolute value. So subtract 5 from both sides. Now, as a side note, when you first initially looked at the example, you saw that it was set with a negative. Don't let that fool you, because you have to isolate before you make your final decision when you see a negative. Now we have this negative out front, so divide by -1. So flip that inequality to 8. Now it flips it so we have a great or, so off to the side, write or to remind you. Now we're going to go ahead and write our two equations. And then change your signs. So add 1, and then divide by -1 and flip that inequality. And then subtract 1 on the other equation, or inequality. So we have our two inequalities. We have to write as an or compound. So remember, all the values of n such that. Now the or compound, you take the smallest number. So you take this whole inequality here and you just drop it down into your answer. Your union, and then n is greater or equal to 7. And then don't forget our graph. So we have our -9 and our 7, closed circle on 9, shading to the left, closed circle on 7, shading to the right. Remember, on the or compound, your graphing goes away from each other. Next example, isolate. So subtract the 6. And then divide by -2. Flip that inequality. Now, it's isolated. We see a negative, huge red flag. It's a great or a negative, so your answer is going to be an all real solution. An easy way to remember this, think of the word or. That R is in here, all real. Last example, isolate. Flip that inequality. Now we have the isolated absolute value. We have this negative, so we have this red flag right here. So since it's less than a negative, you have a no solution as your final answer. And that is it for this section.